Hi guys, one more day and one more lead code task to solve. I want to remember that I'm not doing this to improve my uh, developing skills, but I have a chance to improve my English speaking skills a little bit and uh, start my day with a small win, and I hope I will win next task today. So let's see what LeetCode prepared for me today. Yep. Easy one. Okay. Find missing and repeated values. Find missing and repeated values. We have agreed as input and array as a of numbers as an output. You are given zero indexed 2D integer matrix grid, integer matrix of size n, so squared matrix, with values in the range from 1 to n square. Okay, each integer appears exactly once except a, which appears twice, and b, which is missing. Okay, the task is to find the repeating and missing numbers a and b. Return a zero indexed integer array ends of size 2, where ends 0 equals to a and ends 1 equals to b. Okay, got it. So there is no sequence inside of the grid 1 3 2 2. For example, 1 2 3 4. Here we have yes, we're starting with 1. Here we should return 2 as a repeated number and 4 as a missing number. And here we have grid 1 2 3 4. Missing is 5 6 7 8 8. So we should return 8 as a repeated number and 5 as a missing number. Constraints. Length is always bigger than or equal to 2. Grid I length less. Yeah, grid length is always the size of n and less than 50. Okay. Every value is bigger than 1, so it's positive integer, but less than n square, of course, obvious. Got it? No repeated members. Sorry, I got sick a little bit. There is exactly one x that is not equal to any other grid members. This is a strange condition because we know that every member is unique, so not equal to any grid members. one pair of, okay, got it. So looks like this is a dynamic development where we should simplify this array, we should flatten it, then we should sort it, and after that we will be able to make to loop through the whole array and find repeated and missing values. I don't think there is a solution that would be more simple, so let's try. I remember that in JavaScript we have a flatten method or something like this. Flat, yeah. So for example, if we have a matrix here, how we can simplify it. After that we can sort it with things like with array like this, where we will have a, b, a minus b, oops, sorry, and x be sorted. So we should use b minus a some, yep. Sorry guys, it's the morning. X a minus b, yes, this is how it should work. And after that we can find repeated values and we can find missing values. Actually, we can simplify it a little bit by looking for missing and repeated number during our sort algorithm, but I don't think there is a reason to do it. Actually, we will have the complexity of, let's say, we should flatten all arrays. Let's imagine that we have n is side of n is number of elements of members. Count of members, which is n square, as we know. So the final complexity should be n big O of n multiply log n big O of n. This is a flattening of our array of count of members, okay. And plus big O of number of members, which is the final loop. So in the end we will have this formula. Simplify it, O big O of n log n. Okay, let's start. Flatten is equal to grid flat. Flat? Yep, flat. Flatten. After that we should sort it. How we're sorting it? A minus B. That's it. And after that, let repeated is equal to repeated, and let missing I is equal to 0, I less than n to the power of 2, and I plus plus. Then if we see that flatten of I is equal to flatten of I plus 1, then we tell that repeated is equals to flatten I. Fair enough. Yes, we will have it anyway. Then what about missing one? Missing one can be the last one. So if flatten I plus 1 is bigger than flatten I plus 1, then we can say that missing is flatten I plus 1. But here we have a problem, because the last one would be, for example, in this case, I plus 1, or we're starting from 0. So we have to expect at the index of 2 we will have 3. What will be with the last number? For example, here we have 1, 2, 2, 3. When we're going to E equals to 2, 1, 2, 2. No, we cannot use it because if repeated number is in this, not in the end of the array, then we will have a problem, because every next element will satisfy this condition. We can simplify it. Yes, here we're trying to understand that the sequence is broken. Yep, the first idea was right. But if we don't have, actually, if we have a repeated number, if we don't have broken sequence, it will mean that, okay, first one is repeated, it will always be here, And if missing equal to undefined, then we have to say that broken one is the last one. So let's try with this example. We will flatten it. After we will sort it. E is equal to 0. E less than n. Oh, we don't have n number here. Yep. N to the power of 2 is 4. 4 minus 1, 3. E less than 3. So we will have a loop 0, 1, 2. Let's talk with 0. Flatten 0 is 1. Flatten 1 is 2. If they are equal, they are not equal. Flatten 1, 1 plus 1, 2 is bigger than 2? No. False. Next step. I is equal to 1. I flatten of 1 is 2. Flatten of 2 is 2. They are equal, so repeated is 2. Flatten 1. Flatten of 1 plus 1. 2 plus 1, 3. Bigger than 3. Bigger than 2. Nope. Then I is equal to 3. The last iteration. I is equals to 2. Flatten of 2 is 1 is 2. It's not equal to flatten of 3, which is 3. Okay, skip it. Flatten 2 plus 1, 3 is not bigger than 3. We will skip this one. Okay, as a repeat, we will get 2. Missing is undefined, which means that we will take missing 2 to the power of 2, which is 4, which is a right solution. And here, in the case of missing repeated 9, it will work in the last iteration. And missing 5, here we will go here, because when we will move to 4, here we have for example 4 plus 1, 5. Bigger than, less than 6. Flatten plus 1 would be 6. So here we will have 5, here we will have 6, and we will tell that missing one is 5. That's right. So, in my opinion, it should work, but let's check. I see some problems. Const flatten. Oh, got it. Syntax error. Accepted, yes. 2 cases are solved. Let's try to submit it. Wrong answer. Missing one. Oh yeah, I have not handled the case where the first element can be missing. When we're trying to find the first element, for example, flatten 0 plus 1, we would have 3, and here we will also have 3. We can do another approach. We can say that we have an additional variable missing index or real index that would tell us which index, which number we should compare to. And we will increment real index every time with incrementing I, but when we have repeated number, we will increment it twice. And after that, we can check this thing. If flatten of I is not equal to real index, then we will say that this number is missing. It will not work with the last one because we're skipping the last iteration, but it should work with previous one. So real index is 0. In case of this condition, what we have, real index would be 0, 1, because repeated is found instantly, 2, flatten y, then flatten of 0 is 2 is equal to 2. No, something strange. We will have a missing 2. Maybe like this. We'll have a missing 1. Yep, it should work. So if we have an element with, we should have 1 here. No, we should do this. Yes. If it's not 1, then this, and after that we are making additional increment. Well, that is a problem. It works with this case, but doesn't work with this one. When we're losing... because a repeated number is before lost one. And if we have a missing one, we should decrement real index. Yep. 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 Let's see. Well, missing is 3. That one is kind of strange. Real index 0, 1. We're comparing with 1. Then we see that it is repeating. It's not missing, it's repeating. We're incrementing real index, which means it would be 2. Well, I'm not sure, but no. Well, one. After that, real index would be 2. Next iteration, it would be 3. No, something wrong with that. Real index, we should decrement real index if we're skipping one number. Why we should decrement it? We should increment it, because that number would be bigger, and here we have decremented. Well, maybe it would sound strange a little bit, but yes. No. Same mistake again. So here we have 1, 2, 1, 4, 1, 1, 2, 4. Real index is 1, which means that it is equal to, but real index is 0, then real index is 1. Yes, it will be equal 1 to 1. After that, it will be equal 1 to 1. Yes. After that, real index would be 2. 2 is equal to 2. After that, real index would be 3. But 3 is not equal to 4, which means that missing 1 is 3, but I will get 4 in the end. No, it should work. So let's start from the beginning. Real index is 0, real index is 1, and then we're comparing. Now we found repeated 1, and it's 0 again. Real index is 1 again, comparing with 1. Okay, pass one more loop. Real index is 2, we're comparing with 2. After that, real index would be 3. Here we will have 4. 4 is not equal to 3. This is why we will make it 3. Well, it is strange. I think I should debug it a little bit. Use test case. How to run this particular test case. Okay, got it. We will do it in developers console. Increment missing. Compare. Compare missing and compare repeated. Of course. Compare missing 1 1. Compare repeated 1 1. Yep. Repeated 1, of course. Compare missing again 1 1. Compare repeated 1 2. Compare missing 2 2. Yep. Compare repeated 2 4. Compare repeated 2 4. Yes, but this is the last iteration. We are not getting to next one, where real index would be 3. Yes, because it doesn't satisfy this condition. but we have to compare real indexes anyway. So we need to do this last loop. We can add additional condition. I don't like this solution, but it sounds reasonable in terms of that we have to use yeah, I think it sounds reasonable. Okay, will it work? Yes, it works, but will it work for all the cases? Sounds like yep. Well, this is not the best solution. I think the best one would be something that repeated is 0, missing is 0. Okay, we're not creating additional array. Wow, we're not doing it with sorting, we're just filling existing arrays. So that one is with much better complexity. Yeah, we don't have to sort this array. We just have to allocate the memory in the beginning, because we will have to allocate it anyway. And here we're, yes, count. We're counting the numbers, and in the end we're just looking for missing one. Well, that's so cool. This solution, I like this solution very much, so much. Of course, my solution is not the best comparing to this one. Well, there is a lot of things to learn for me, as I found out today. But yeah, that was the nice beginning of the day. I spent 40 minutes for this task, and I hope next time I will have a chance to improve my result, especially because the previous task was pretty similar. It was also not the previous, this one maybe. Nope. So that there was a task where we had to allocate the numbers from the beginning. Yes, here. Yes. This is a really nice trick where you can just allocate the memory in the beginning. Yes, allocate the memory in the beginning and then just fill this allocated memory, this allocated array. And because we're dealing with the not just like sequence of number. We're dealing with the sequence that should represent the incremental sequence. Well, really nice task. Like it. Thank you very much.